Hey, what's up, everybody? My name is Moss, and this week I'm attending KubeCon 2024. I'm going to summarize some of the key insights from the sessions that I attended so that you don't have to watch 12 hours worth of video. I'll also be interviewing attendees and speakers at KubeCon while I'm here. November 12th was Observability Day at KubeCon, and it was busy. There were a lot of people interested in how they can integrate observability into their software development lifecycle, and specifically, the focus was primarily on OpenTelemetry. Speaking of OpenTelemetry, let's dive into the session summaries. Observability Day was kicked off with OpenTelemetry project updates. The maintainers first discussed the status of OpenTelemetry in the CNCF graduation process. And OTel demonstrated maturity and stability following a third-party security audit of the core SDK, API, and collector. And now the team is focusing on stability with ongoing work towards a 1.0 release of the collector. And the database and HTTP semantic conventions have reached a stable status. A recurring topic throughout the entire day was profiling. And the maintainer team announced that profiling is set to become OpenTelemetry's next key signal, integrating Elastic's system profiling tools into the collector. They also discussed their efforts to simplify instrumentation, which included integrating eBPF tools like Bela and also adding Go compile time instrumentation. And finally, they announced a new certification program. The OpenTelemetry Certified Associate certification will be covering the API, SDK, collector, and data model, and you'll be able to take exams for the certification starting in 2025. The next session I attended here was Profiling Mastery, which stressed the importance of implementing profiling. Some key insights here is that small code changes and optimizations can have a really large impact on costs. And continuous profiling enables in-depth troubleshooting and deep insights into your application's efficiency. The good news is that if you're a Splunk customer, you've had access to continuous profiling for a while. The speaker discussed that if you implement the eBPF agent, it supports a large number of languages and incurs only a minimal amount of resource overhead, less than 1% CPU and less than 256 megabytes of RAM. They also mentioned that it's difficult to correlate performance data with OpenTelemetry traces and spans. How do you know which thread handled a particular GET call on some endpoint on your website? So you can use global variables and thread local storage by using the OTel SDK extensions for explicit span process correlation. The next session that I attended was a panel discussion that included engineers from GitHub and eBay. The panelists emphasized a need on reducing cognitive load for developers when integrating OTel into their environment. You want to minimize the amount of work that is required for a developer to integrate observability into their software and gain the benefits of OTel and observability. One of the challenges that was highlighted, and like I said before, was a recurring theme throughout yesterday's sessions, was profiling and also reducing resource intensity of OTel instrumentation. The panelists also emphasized translating observability into business outcomes so that their broader organization is willing to adopt observability. So observability shouldn't just be about, hey, we have 10, 20 servers that are reaching 95% CPU utilization. It should really be about, hey, over the last hour, this number of orders on our e-commerce site failed. Those are business outcomes that the entire organization should be able to understand and relate to. The next session was discussing auto instrumentation and when and where to use auto instrumentation. The speaker discussed multiple ways that you can auto instrument depending on the language that you're using, whether it's a compiled language or an interpreted language like Python and JavaScript. And auto instrumentation is great as a starting point for bootstrapping distributed tracing in complex or legacy services, or where you can't modify the code, so in off-the-shelf software. But if you implement auto instrumentation, you still need to manually annotate your trace data to get things like user context and business-specific metrics. The next session talked about build time auto instrumentation in Android. Unlike regular JVMs, Android doesn't support using Java agents. However, you can use the ByteBuddy Gradle plugin, which enables build time bytecode weaving. So all you need to do is add the plugin and relevant libraries to instrument Android apps without altering source code directly. And in the future, they'll potentially add a with span annotation for deeper traceability. I attended a distributed tracing session hosted by Vijay and Sandeep, who are eBay engineers, and they discussed the challenges of implementing observability at eBay. As mentioned in the panel discussion, they emphasized the need to reduce developer cognitive load, and they did this by providing a managed framework for automating trace instrumentation across all of the development teams. Another big challenge that they faced was controlling their costs, and to do this, they implemented adaptive tail-based sampling and used selective retention of high-value traces. The key takeaway here is that they automated and standardized instrumentation in their organization, and then they used cost-effective sampling strategies that kept their costs manageable while still retaining valuable trace data. The next session focused on how you can simplify OpenTelemetry's configuration. Using a traditional OTel configuration approach, you have to rely heavily on environment variables and programmatic approaches. But this can be cumbersome, and especially programmatically, it's inconsistent across languages. So they presented an alternative declarative file-based configuration in YAML format, which is language agnostic, structured, and it can handle complex scenarios. Essentially, you can use one configuration file to control the instrumentation of multiple services that might be written in multiple languages. And you can do so without writing a lot of instrumentation code in each of your applications or using environment variables and other complex configuration. In this session, the focus was primarily on how do you maximize the value of your telemetry data while still optimizing for costs. Again, this was a really important theme throughout the entire day. A lot of companies are trying to optimize for cost while still retaining valuable data that they need to properly observe their applications. And the speakers discussed various approaches that you could utilize, like data filtering, tail sampling, routing to different storage backends. So for instance, maybe you have a low cost, long-term storage solution and then also a faster, more expensive storage solution. You might want to route data depending on your retention levels to specific storage backends to optimize your cost when data is stored. And they also talked about transformations of data to reduce costs as well, like high cardinality data. I've linked the full recording of each session in case you do want to watch a particular session in the video description below. Thanks for watching, and stay tuned for more updates throughout the week while I'm at KubeCon.